Hello and welcome to Young Minds versus Physics, Madhavi's Physics. Alright, so horizontal motion, horizontal force. Right, we shall see smooth surface, rough surface, smooth surface. See, any body resting on a surface experiences weight vertically downwards. Surface applies normal reaction vertically upwards. Nothing to be worried, these two will get cancelled and the body is in equilibrium. Now, when you apply a force, what did we say? Horizontal force. When a force F is applied here, how does the body move? Here the surface is smooth surface. Right? According to Newton's second law of motion, body will continue to move or stay in the same state of rest or motion until an external force is applied. Now till now, these are the only two forces which are acting and the net effect on the body is zero, therefore at equilibrium. Now a force is applied on this, thus body will now try to move in this direction, and here the surface is smooth. Whenever the body is moving on a smooth surface, there is no friction, which is ideal condition. Right? That means when there is no friction, then the body moves with the force with what is applied. That means now the force is equal to mass into acceleration of the body, and acceleration of the body is equal to F by m. That's all. Right. Now coming to rough surface. Now here the case is not smooth, rough surface. The same weight acting vertically downwards, normal reaction vertically upwards. The body is in equilibrium. That is at rest right now. Now a force is applied, F, horizontally. Now the friction starts acting, right, at the surface of the contact opposite to the force applied. And that friction has got some magnitude, and here two cases will arise. Case 1, right, depending on the surfaces in contact, frictional coefficient of friction mu s will be there, and the maximum frictional force is static frictional force, which is equal to mu s into normal reaction, and of course normal reaction is equal to mg. I repeat it here. When a force is applied on the body, now the friction starts acting opposite to this, opposite to the applied force, right? And here we will take two cases. Case 1, when the body is yet to be moved or it is about to move. It is not moving right now, it is about to move. That is maximum frictional force acts on the body, and that is equal to mu s into n. Right, now it is only about to move. Right, that means what happens? Why am I saying that it is about to move? See, it is not necessary that on a rough surface you have a heavy body and you applied some force that it starts moving. It is not necessary, is it not? See, that means the force should be sufficient enough to make the body move. Why do you think that the body is not moving even though you are applying force? Why? Because as you started applying a force to make the body move on another surface, right? So the friction which is there between these two opposes the force applied or opposes the motion. So what happens slowly? The friction, like as you are increasing the force, the friction also increases. And there is a limit for it, right? That is called limiting friction or the static friction. So there is a limit. Beyond that, it can't. If that is the case, nothing in this world can move because smooth surface is ideal condition, right? So practically there exists always a friction. So if the bodies are moving, means definitely friction has got some limit at a point. So that is called limiting friction. Now when the friction has become maximum there, right? So then beyond that, if you start applying the force, now the body moves. Now the body moves. As the body is in motion, now the friction decreases. Now the friction decreases. So therefore, there will be two conditions. One condition is when the body is about to move, right? That is the maximum friction when it is acting, right? Now after this, case 2, mu k, that is coefficient of kinetic friction acts here, right? And mu, what is Fk is equal to, kinetic means when it is in motion, mu k into n is Fk. Right, so what did I say? As the body starts moving, now the friction falls from static friction or the limiting friction to kinetic friction, and now it becomes easy for the body to move, right? So therefore, with what force does the body move now? The body moves, right? Like so, here is F, here is Fk as it is moving, suppose. Then it moves with a net force of F net is equal to F minus Fk. F net is equal to the net force with which the body moves here is F minus Fk. Now we are not bothered about these two because they cancel each other, right? Like the effect of these two on this body is nothing. It's not moving. It's at rest. Now the only forces you have to take into consideration is the force which is applied in this direction. And as the force is applied in this direction, body has to move in this direction. But it is not moving because of opposite force pulling it backwards. And what is that pulling force called? That is frictional force. That is frictional force, right? So now bodies won't move until you apply some more force. Like where the body is ready to move, that is the maximum opposing force. That is the maximum opposing force. After that it can't. Now after that it can't apply the force. That means the friction cannot stop it, right? So therefore what happens? Now additional to that one, how much ever force you are applying, right? Now the body starts moving. Once the body starts moving, there is, the friction doesn't become zero, but it reduces. Once one body starts moving, it reduces, right? And that reduced friction is called kinetic friction. Okay, so now with what force it moves? In one direction it is F, in the opposite direction it is Fk. So therefore net force is equal to F minus Fk. Right, and therefore acceleration is equal to F minus Fk by m. This is the acceleration with which it moves. That's all. Today we are only discussing about how to find the acceleration in horizontal motion and when a force is applied horizontally. Right, horizontally parallel to the surface. Here, horizontal surface. Right. Done, and wait for the next series. Thank you for watching. I have recently started my channel. Please subscribe, share and support. Once again, thank you for watching the video.